All right, hello everyone. Welcome to the Ecological Forestry in the Context of Climate Change webinar series. Welcome from the U.S. Fish and Wildlife Service and the National Conservation Training Center here in Shepherdstown, West Virginia. My name is Gwyneth Daunton, and today's webinar is titled Ecological Silviculture for Oak-Dominated Ecosystems in the Central Hardwood Region. And we have Miranda here today from Ohio State University. And we will be introducing Miranda a little bit more later, but we need to remind you of some pre-webinar items first. First comes first, we do have closed captioning for this webinar, and so if that's something that you're interested in, please let me know and I can help you out with that. I would like, though, to start with the NCTC's land acknowledgement. The National Conservation Training Center is located on the ancestral lands of many indigenous peoples. These include, but are not limited to, the Massawomac, the Haudenosaunee, the Shawnee, and the Delaware. NCDC is dedicated to building relationships with indigenous communities, and we encourage others to learn more about the lands that they reside in. If that interests you, I can share a link with you so you can learn more about the inhabitants that work and lived on the land that you work on. We also want to try and be the most inclusive as we can. We welcome all students here at NCDC, and it is my intention to create a safe, inclusive, and productive webinar environment that honors and supports diverse ideas. We are strengthened by diverse perspectives and identities, and we foster environments where everyone can learn new skills, as such, I will be an ally in events that anyone experiences accessibility issues or feels unwelcomed. We have some ASL interpreters here with us today, which is quite lovely. But if any time you feel unwelcome, please raise your hand or message me directly and I can help you out. Also, a disclaimer, this product is for educational purposes only. The views, opinions, or positions expressed in this webinar series are those of the guest presenter and do not necessarily reflect the views, opinions, or positions of the U.S. Fish and Wildlife Service or the Department of the Interior. Some of the materials and images might be protected by copyright or may have been licensed to us by a third party and are restricted in their use. Mention of any product names, companies, web links, textbooks, or other references do not imply federal endorsement. That being said, we do have quite a few wonderful references for you guys. And so you can check that out. They're all in the chat. So unfortunately, you guys are all muted. This webinar is being recorded and we still want to hear from you though. In the chat, you can go ahead and start introducing yourself. And so you can go ahead and do that so we know who you are and where you're from. And at halfway through the webinar, we're going to ask you guys if you have any questions. And so you can go ahead and put the questions in the chat and we'll refer to the chat halfway through the presentation and then also at the end. Make sure that when you are messaging in the chat that you have it going to everyone and not just the presenters and the panelists. Also, this is the best way to view the presentation. And so as you can see down here, the side-by-side gallery is the best way to not only see the presentation, but also see the instructor and also the ASL interpreters. And without further ado, I'm going to pass it over to Maria.
Wonderful. Hello, everyone, and thank you so much for coming today. This webinar is part of the series on ecological forestry in the context of climate change, and we're excited to see a really great turnout this afternoon for today's talk. My name is Maria Genoviak. I'm the acting director of the USDA Northern Forest Climate Hub and the Northern Institute of Applied Climate Science. I work for the Forest Service. And I'm one of the folks who've helped to plan and carry out this series, as well as a prior one, where we've really brought together the folks from the Fish and Wildlife Service and USDA to focus on a number of topics that are of interest to people related to wildlife, forest management, and conservation. and climate change. So we're really happy to be here. Some of the co-hosts of this series include from the Fish and Wildlife Service, the Forest Ecology Working Group, the Science Applications and Migratory Birds Program, and the National Conservation Training Center. And then from the USDA, we have the USDA Northern Forest Climate Hub, the Northern Institute of Applied Climate Science, and the USDA Forest Service. And so this has been a really wonderful collaboration. I'm really excited about this. And we do have our contacts here if you have any more interest in the series. And I'll also post the link to our page for that. All right. Next slide, please. So today's webinar is part of a monthly series that looks at how a variety of disturbances affect forest ecosystems. In this series, particularly, we are examining ecological silviculture and climate change adaptation approaches to help inform forest and wildlife management. I'll introduce today's speaker momentarily, but I also want to note that our upcoming webinar next in this series is Ecological Silviculture for those southern bottomland hardwood forest ecosystems. That will be by Haven Barnhill of the U.S. Fish and Wildlife Service on June 18th. And so hope you'll come back for that. We have been posting presentations. They are recorded. We have been posting them to the website for this particular series. And so next slide. So today's presentation is on ecological silviculture for oak-dominated ecosystems of the Central Hardwoods region. And our presenter is Miranda Curzon, who is an assistant professor at Iowa State University. Dr. Curzon's research looks at ecosystem responses to stress and the silvicultural strategies that can be used to restore ecosystems and build adaptive capacity. And she has research across many sites, long-term study sites in the Midwest. In this presentation, she'll be discussing drivers of change in oak-dominated forest types, which includes wind, floods, fire, pests, and invasive species. And we'll also discuss how one experimental trial, the Adaptive Silviculture for Climate Change network experiments, will help to provide some site-specific examples. Just to reiterate, we encourage you to ask questions using the chat. We will stop about halfway to ask 1 or 2 questions, and then we'll have more time for Q&A at the end of the presentation. And so unless, Gwyneth, you have anything else, I will turn it over to Miranda.
All right, Miranda, I'll stop sharing and then you can share your slides.
Okay, can you see my slides? Great. Right, well, thank you, Maria, for the introduction. I also just want to say thank you to the U.S. Fish and Wildlife Service for hosting this and all the other partners and organizers who have made it happen. I have really enjoyed the series so far, and I appreciate being invited to participate. So as Maria said, I will be talking about ecological silviculture for oak-dominated ecosystems in the Central Hardwoods region. And much of the material that I'll be covering today comes from a book chapter that I co-wrote with John Cabrick, who's a forest scientist, forest ecologist with the Northern Research Station at the U.S. Forest Service. And then I'll also talk a little bit about a case study or an example of some of these ideas in practice. We're using some of the approaches in an adaptive silviculture study, just like Maria mentioned. And so that serves as an example of some of these things on the ground. Just to start, I know that this is a familiar idea to many of you, especially if you've tuned in to other talks earlier in the series, but to make sure that we're all on the same page, I just want to define ecological silviculture. It's an approach broadly for managing forests, and not just trees, but all of the associated organisms that prioritizes ecological function in that management. And it's based on natural models of development. And so informed by what we know about the natural disturbance history of those ecosystems. And it relies on 4 main principles, which I'll reiterate throughout the material that I present today. Those principles are continuity, That's largely achieved through the maintenance of biological legacies that provide continuity over time before and after a disturbance and a stand, complexity and diversity, timing or recovery periods, also informed by that natural disturbance regime, and then context. So thinking more broadly about what's going on in the landscape, on adjacent properties, because they're all interacting and influencing one another. And much of what I'll be talking about is coming from 3 very recent texts that have built on a few decades of work in ecological forestry and ecological silviculture. And as I mentioned, I'll present material from a chapter in the ecological silviculture systems text that just came out this year. So our focus in that chapter is on the Central Hardwoods region. This is a big region across the eastern United States. It includes 5 ecoregion provinces, excuse me. And we define the boundaries of this region based on a recent paper that Bryce Hanbury led. There are a number of different ways that the region is defined, but there are several things that tie it together. And one of those is a dominance of oak and hickory species in those tree-dominated ecosystems. Ownership across the region is largely private, and that has a huge impact on management of forests and woodlands. Many of those properties are small. So in some places, you know, the mean property size is 50 acres or more. But then in other states like Iowa, where I'm at, those properties on average are smaller than 20 acres, and they're getting smaller over time, becoming more and more parcelized. The forests and woodlands are highly fragmented, in part because of that parcelization, but because of other drivers also. And even though in some parts of the region, that fragmentation, some level of fragmentation has occurred historically. For instance, in Iowa, you know, we have this mosaic of prairie, savanna, woodland, forests. So it's a patchy landscape to begin with. When you've got development and other things that are really driving that fragmentation, it has a huge impact on how those ecosystems function. This landscape is heavily influenced by development. A large proportion of the US population lives within the Central Hardwoods region. It's also influenced by agriculture. There are a lot of, in our forests in Iowa and in the driftless area, which I'll be focusing on, most of them are adjacent to row crops. And that leads to a lot of interactions between, you know, what's going on with agricultural production and our forest ecosystems. They're impacted by invasive species, like most of the forest ecosystems across the US. And then they've also been impacted by land use, and that includes fire suppression and fire exclusion. And because they're dominated by oak and hickory species, or have been historically, that absence of fire and that change to that disturbance regime has had a huge impact. Oak species characterize these forests and woodlands across most of the region, even though it is a very rich region in terms of species. There are over 100 species that occur, there are many more than 100 species, over 100 tree species that occur in these tree-dominated ecosystems. And I'm being very intentional by referring to them as ecosystems rather than just forests, in part because it's important to distinguish savannas and woodlands and forests. And we do that with some of our work with these ecological silvicultural systems. So I've got an adapted stocking chart on the screen here. This is adapted from the classic Gingrich stocking chart from 1967. John Cabrick, Bryce Hanbury, Dan Day, and others, David Larson, Ben Knapp, Lauren Pyle Knapp, worked together to produce a publication that uses this stocking chart to inform how someone might use a traditional silvicultural tool to restore an ecosystem so that it has a structure like what you would expect with those different ecosystem types. So with our forests, those are typically fully stocked. You have a closed canopy, generally multiple layers, greater than 70% stocking, looking at the stocking chart. And there tend to be some other things that are associated with that. With a forest, with that structure, in the understory, there are more spring ephemerals that take advantage of that early spring light, but then are adapted to being able to persist in close canopy conditions throughout the rest of the growing season. And you see fewer of other species in more early successional habitats that are really important across this region, like occur in both open and closed woodlands, where that canopy is maybe close to closed, but not fully closed. Stocking is between 30 and 75%. There's a lot more sunlight reaching that understory, but there's still enough competition that you have crown classes developing. And the midstory is much more open. It's a somewhat simpler structure, but in the understory, you tend to have a much greater, you can have a greater species richness, and you tend to see more species like milkweed and asters, more graminoids that are really important for other biota that are reliant on them. And then the savanna is defined, at least using the stocking chart, as having a stocking between 10 and 30%. So far fewer trees, just a few per acre. And these trees are, they can be clumped or dispersed across a site, an area, but they tend to have dominant full crowns. They're open grown, and that understory looks very different. So they tend to be dominated by grasses, and there are other species too. And something else to note, just with there's been a recent interest and emphasis on pollinators, and there are a lot of species that are really important for pollinators in these savanna and woodland ecosystems. And so that leads me to a key point related to ecological silviculture in these systems, and that's that open forest ecosystems are an important component of this region, both ecologically and culturally. They've been maintained over time through prescribed fire applied by indigenous peoples, and they are really important ecologically for the species that have adapted to them being there. And so an ecological silvicultural system for this region, for these oak-dominated ecosystems, really should have a greater focus on ground flora at least at some points in development, maybe even than tree recruitment. So this is a list of common tree species and their characteristics for the region. It's small print, and I apologize for that. I don't intend for you to read the whole table, but I just want to highlight some of the common oak and hickory species. And really the main point that I want to make is that many of these species are long-lived. You can see that, on average, they're mostly between 200 and 400 years for the longevity, the max longevity. And they also tend to have a fairly high drought tolerance. There are other stress tolerances too that are favorable for them. And then drawing on some of the work that was put into the Climate Change Tree Atlas, I pulled the adaptability scores. This is an index that's based on a number of over 20 variables, I believe, related to the biology of these species and how they respond to disturbance and stress. It ranges from the least adaptable species I've seen was, I think, around 2. I don't remember what the exact is. And then red maple, I believe, has the highest ranking of all of the species that were considered. And so if you think about that range, a lot of the species that we have in the Central Hardwoods region are really fairly adaptable. And so as I talk more about some of the vulnerabilities of these ecosystems and climate change, we've got a pool of species to work with. So there's an opportunity there, some good news. But before we get there, we do have some challenges in the region that we're already working with. And one of those is figuring out how to successfully regenerate our oak species. So this is a highly variable region. Soil quality varies quite a bit, as do the disturbance regimes, depending on where you are. Topography varies, richness, moisture gradients. And so when you're considering a site, on the whole, if you're working with a drier site, poorer soils, your options in terms of that light gradient, so the silvicultural treatments that you might apply to manipulate the overstory, tend to be much wider. So you've got greater opportunity there in terms of light to be able to regenerate oak successfully. But on those sites that are moister and richer, other species that are more competitive tend to be successful and outcompete oak. And so you just have fewer options. Another consideration here is the disturbance regime. And so we tend to focus more on mean return intervals. So the average time between disturbance events, at least historically, but the variability in those intervals can also be really important. And that's what's illustrated in the figure in the lower right. So if you have maybe a short mean fire interval, but those fires are occurring very, very regularly. So on average, the mean fire interval is between 2 and 10 years, but they're occurring every 3 years. If you're applying that knowledge to your management, for instance, and you're trying to use a prescribed burn too frequently, you may end up with a graminoid dominated system. So a prairie or a savanna when you're hoping to actually recruit oak. So that variability is important. You need some breaks from the fire in order for these trees to be able to establish and recruit to a size where they're more resistant. In addition to fire, even though we do tend to focus on fire, in addition to fire, wind, insects, and disease also influence oak ecosystem dynamics. They have historically, and we also have changes. We have new agents that are influencing these systems. So this is just an example from central Iowa. This is a forest that I visited in 2018. It's dominated by mature white oak. The picture doesn't do it justice. It's a really gorgeous stand, and it's a cool property. It's still owned by the family that homesteaded it in the 1800s. Well, this property, the landowner is really responsive and a great steward of the property. He was trying to make sure that he had oak regeneration in the understory, and then there just wasn't any. And so he and the district forester were using prescribed burning and a number of different practices to try to encourage oak to establish, to try to get advanced regeneration. And then in 2020, we had a derecho in Iowa that impacted a lot of forests across the state. Unfortunately, it impacted this particular stand. And even though, I mean, there was damage across the stand, most of the trees survived. But then in the years that followed, there was more oak wilt and then also a lot more insect activity and saw decline and then a lot of mortality. And so now they're working in that stand. They're trying to regenerate it, but because they did not have advanced regeneration present in advance of those disturbances and everything that happened afterwards, they're now having to plant, which, I mean, it's a great option, but ideally they would have had regeneration ahead of time. Some other factors that are contributing to that are invasive species. In this particular site, they did not have a problem with bush honeysuckle or European buckthorn or some of the other shrubs that can be problematic. But there are definitely other factors that are influencing regeneration. Emerald ash borer is another it's another insect that folks are very familiar with. It has impacted forests across the eastern U.S. It arrived in Iowa or became abundant, and people were observing mortality starting in about, so I don't know when it was starting, but it became more widespread in 2018, 2019. Now I believe it's in almost all of the counties. But that has also impacted these dynamics. And so what's going on in the understory is really important, because if we don't have advanced regeneration, we don't have what we're hoping to recruit when these events happen. We're stuck. We have less to work with. So across the region where silviculture is applied, clear cutting and conventional shelterwood methods are the most common. And I with that language, where silviculture is applied, what I'm also saying is that much of the management is actually passive. And there's a fair amount of high grading that occurs in these forests and woodlands as well. And that's led to degradation over time. So we either have these stands that are succeeding to more mesic species because they're not actively managed and there is no fire, or we have degraded stands that are being high graded. And then on the other end of the spectrum, we have stands that are being simplified through the application of even-aged silvicultural methods, which are successfully regenerating oak, but also have some disadvantages. And so that brings me to another key point, and that is that regeneration harvesting should prioritize biological legacies in these systems if you're applying an ecological silvicultural system, because that helps to maintain a healthy and diverse understory, and the structures that are created reflect the dynamics of these ecosystems and help to support all the organisms who have adapted to them over time. And so now I'll go through the broad developmental model that we produced for these oak-dominated ecosystems. And it is very broad, so it's important to keep in mind the specifics of a disturbance regime in whatever area you're actually working in. But in general, in the disturbance and legacy creation stage, in this region, we tend to see partial canopy disturbances. So some can be near stand replacing, but on the whole, it's mostly partial canopy disturbances that leave live tree and deadwood legacies. And so depending on whether you're in a forest ecosystem, a woodland, or a savanna, the resulting structure can look a little bit different. And then following that legacy creation stage, we enter the pre-forest stage. And in this stage, oak and hickory sprouts, if they're present, if there's advanced regeneration present, dominate forests and woodlands alongside a significant herbaceous component. And those herbaceous species are very important. They support a lot of wildlife. And the length of this stage is largely determined by what woody species are present. So if there is abundant sprouts, oak and hickory sprouts, we can actually move through that stage very quickly as they recruit to the canopy. But if they're not present, or if there is recurrent fire, then the stage can last up to 50 years. There's a lot of variability there, depending on the context and what is impacting it. And so another key point related to this is that pre-forest stage is really important. It provides valuable early successional habitat. And that's habitat that is not as common across this landscape as it used to be. And it's, as I mentioned, pollinators earlier, that's one group that is really dependent on it, but there are other species that are as well. And in woodlands and savannas, characteristics of this pre-forest stage are also present in other stages of development. So this is there are some commonalities. There's continuity over time. In the young stage, oak sprouts tend to recruit to the canopy. And usually there is an absence of fire during this period that allows that recruitment to occur. And then thinning can result from either recurring fire in the savanna and the woodland types, or once competition sets in, you see self-thinning in the forests. And then during the mature stage, we have oaks with wide crowns dominating the overstory. This is where deadwood starts to accumulate. So snags in the overstory as well as deadwood on the forest floor. And with openings in the canopy, you tend to see the plant species diversity increase again. And that's in the understory of savannas and woodlands that can be in the herbaceous layer. And in forests, you tend to see an increase in diversity in the seedling layer. So maybe more mesic species are starting to get established in the understory. And then during the old growth stage, that overstory structure becomes more complex. And this is subtle in these systems. So it's decadence in these oak-dominated systems looks very different than it does, say, in a coastal forest in Washington. But there are still these structures that do develop with these old trees. And that structure becomes more complex as some of them die, as new cohorts recruit, and as additional deadwood continues to accumulate. So depending on which ecosystem type you're in, this can look different. In savannas and woodlands, recurring fire can continue to encourage the establishment and recruitment of oak stump sprouts. And then in forests, you tend to have those layers developing if they're not already present, and more shade tolerant species establishing in the lower strata. And so I have one last key point related to these ecological silvicultural systems, and it's that the application of those treatments should reflect the best available knowledge of the natural and historic disturbance regime. So that's going to be very, very different depending on where you are. So that the timing and the severity will be very like location specific. And as I mentioned earlier, the conventional approaches in this system, or in this region, excuse me, tend to be irregular shelter wood, clear cutting, seed tree, those are very commonly applied methods. But really the desired future conditions for these ecosystems, if we're prioritizing the ecological integrity of them, include having a multi-cohort structure, maybe 2-cohort structure, depending on the particular historic disturbance regime. More complexity in both the vertical and horizontal components of these stands than you would get with those even-aged treatments, those even-aged regeneration methods, both standing and down dead wood. And then also just generally a species composition in all layers that's reflective of that natural disturbance regime. And so really using irregular shelter woods or other similar methods that involve partial harvests are more analogous to what would happen with those natural disturbance regimes. And so this is the ecological silvicultural system that we have proposed, or systems, because it varies a little bit depending on the ecosystem type that you're working in. And generally what we have recommended is the application of an irregular shelter wood in those forest ecosystems because of the opportunity that they provide for increasing the complexity of the structure of those stands and encouraging multiple cohorts over time. There's a lot of flexibility in those. Tara Kaiser talked about expanding gap irregular shelter wood in her webinar last month. And with our silvicultural system, we decided to focus on the continuous cover irregular shelter wood system. Both are just defined really well in a paper that Patricia Raymond led in 2009. I highly recommend. She makes it very accessible. But they are options. Both of those are options depending on what your objectives are and what systems you're working in. For woodlands and savannas, we recommend using variable retention harvest or clear cut with reserves. You can there are a few tools that you can use to achieve some of those structural conditions that are associated with those ecosystems. But whatever you end up applying, an effective ecological silvicultural system for this region needs to be dynamic, and that can be complicated, but it's necessary in order to achieve those ecological objectives and encourage adaptive capacity. And that's something that we tried to capture with this diagram. That's what all the arrows are trying to indicate. So at each point in time, there are different options and different pathways that you can encourage a particular stand to follow, and different treatments that you can apply in order to do that. So I'll talk just a little bit more about the continuous cover irregular shelter wood. This is a figure from Raymond et al. That illustrates it in comparison with 2 other common irregular shelter wood methods. And it's the continuous cover is in the middle. And the main way that it differs, and one of the reasons that we selected it for oak-dominated ecosystems, the Central Hardwoods region, is because it's a little bit more flexible. So the harvesting pattern is varied. It can be single tree, openings, group, free. You have, it's both complicated, but also freeing to have a little bit more flexibility in what you decide to do. And there's also these periods of time, like more variable periods of time between entries that can be determined based on those recovery periods that are appropriate given the disturbance regime. Both the vertical structure and the horizontal structure are irregular, and there is a mix of cohorts that's encouraged. So ultimately, you can encourage a multi-cohort structure with this. And there's no final removal like there would be with a traditional system. So overall, going back to some of those main principles that underlie ecological forestry, diversity, variability in structure, timing based on those natural disturbance regimes, and being mindful of the community composition in the understory, if not on trees, on herbaceous species and other species, should all be prioritized in order to promote native biodiversity and maintain adaptive capacity. And that adaptive capacity serves as a segue to focus on climate adaptation, which might be a good opportunity to pause.
Awesome. Thanks, Miranda. I'm so glad that you gave the refresher on shelterwood. I think I need it no matter like how many times, and I know people here are familiar, but that's really great to have. Let's see here. So I have two questions that I think are good in terms of talking about the ecology before you get into some of the examples. Suspect you may have anticipated this one, but a question about, can you discuss the role of deer browse related to regeneration and recruitment in overall forest health?
Yes, I mean, I suppose that's easy to answer. They didn't ask for a solution, so yes, deer browse is definitely a factor, and I should have mentioned that. Not mentioning it was an oversight, because it is definitely a factor, and that's also something that, at least in this part of the Central Hardwoods region, that's a difference that we see between private and public land. It tends to be more of an issue on private land, whereas hunting pressure is a lot higher on public. And so we see a need for shelters and other things if folks are wanting to protect that regeneration. That is definitely a driver. One of the many things that is complicating oak regeneration.
Yeah, that definitely makes sense. And also kind of the interactions with the oak and invasive species as well in the understory when you have them. So thanks for touching on that. One other question is related to just in terms of oak savanna on that kind of continuum of different forest conditions. So are oak savanna conditions significantly more difficult to create and maintain on more mesophytic sites, on wetter sites, which you kind of discussed? And then are there kind of, maybe even for people who are working in the field, any examples of when you may have a site versus, indicator species, or when you may have a site that would be more conducive to a savanna versus not?
The short answer is yes. So, and there's guidance out there that's not something I know as well. It's not my specific expertise, but in Iowa, for instance, we have bottomland savannas, which are fairly interesting. And it would take me a little bit of time to actually pull that up. But if the person who asked that question, if you're interested, I can actually point you to some of those things, because there has been some research in Iowa on that specifically. And then as far as indicator species, yes, there are. And there are a few, those are a few resources I wish I had thought to include in that list, because there are some resources that are very specific about some of the indicator species that you would expect. And something that we do here is often look at the soil maps and use those to interpret what ecosystem type you would have expected in the past, because the soils are very different for savannas relative to even woodlands and forests. So there are a lot of resources and tools. You just have to find them, but feel free to reach out.
Great, thank you. I think that is what we have for questions for now. So I'll let you return to your presentation and encourage everyone else as we go through the remainder of the presentation to put their questions into the chat.
Thanks, Maria. All right, so now we're gonna switch to a very special corner of the Central Hardwoods region. This is the driftless area. And it's been a really interesting area to work in. There's kind of a mystique associated with this region. I love this quote, but the topography and the geology of the region are different from the surrounding area because, for a variety of reasons, it escaped the most recent glaciation or glacial periods. And that's part of what makes it so interesting, because it does have some relic species that are separated from the majority of their range. So we've got like Canada yew and balsam fir and little pockets in Iowa that you wouldn't otherwise expect. But in this region, there are many of the common challenges that I mentioned or in the driftless area, sorry, there are many of the common challenges that I mentioned for the larger region. We have issues with invasive species. Spongy moth is knocking on the door. So there, the picture on the left there is illustrating bush honeysuckle that's present in the understory. In terms of products and uses, we're very proud of our black walnut. We also produce white oak, though can't compete with Kentucky and other states further east. There is not a pulp market, and so that influences the feasibility of some treatments. And we are seeing kind of a loss of some of the infrastructure, so fewer sawmills, just like in other parts of the country. Agriculture is a huge part of this landscape and has been for a very long time. Indigenous peoples produced through agriculture, 1,000 to 2,000 years ago. And so that's been a component of this landscape, as has fire, through their management. And so it's a very interesting landscape. It's one in which land use change and a number of other factors have already complicated regenerating oak and forest management in general. And there have also been a number of changes to the climate observed in the last 50 years that we expect, 50 to 70 years, that we expect to continue. So I'll just walk through those because they inform some of the treatments that we designed for this adaptive silviculture for climate change study, and then bring that together with those silvicultural systems that we ended up prescribing. So on average, annual temperatures have increased, much like they have in other parts of the country. And the changes in the winter have been the most substantial. So average winter temperatures have increased 3 to 5 degrees since 1950, and the winter minimum temperatures have also increased. There has been more precipitation. So precip has increased by 20% or more, depending on exactly where you're at, since 1950. It's expected to continue to increase. However, because of a number of other factors, we do anticipate greater water stress in the future in our forests. And that's in part because of an increase in the number of heavy precipitation events. So even though we're getting more precipitation, it's occurring in these really intense events. And that's expected to continue. Just as an example, when we, the Adaptive Silviculture group, went out to visit sites to see them so that we could develop our treatments, we actually had a tornado warning and torrential downpours that washed out a road. So we were living some of those anticipated climate changes in real time. Another factor is lengthening growing seasons. So the frost-free growing season has already increased by about 2 weeks, and it's expected to increase by an additional 20 days. And this could increase production in this region, but it does also mean that there's greater demand on water resources that could become more limiting. And so given those changes and some of the other concerns, I worked with a group of partners to start an adaptive silviculture for climate change study in the driftless area. And we're just one of many studies in this network. I've included this map so that you could see where those are at if you're not familiar with the network, and check them out. There are details related to that on the adaptivesilviculture.org website. But we're going to focus on the driftless area. And like all of the other studies in the network, our climate adaptation treatments apply 3 different strategies. And what those treatments actually look like is different at each site, because it's very site specific. And it's developed by a team of folks who apply the latest and greatest information on climate science and ecosystem vulnerabilities and projected habitat for these species. So those 3 treatments are resistance, which is designed to improve forest defenses in the short term, really try to maintain what's there. And then resilience has a slightly different goal. It's intended to give these ecosystems kind of what they need to accommodate some change, depending on what's ahead in terms of stress and disturbance, but then eventually return to a desired future condition or a prior condition. And then the third adaptation treatment is transition. And that with that treatment, the goal is really to facilitate change, to sort of push the envelope a little bit and encourage these ecosystems to adaptively respond to future conditions. And where the greatest overlap is between adaptation silviculture and ecological silviculture, at least in our particular study, is with the resistance and the resilience treatments. So I'll talk a little bit about our study and those treatments that we've designed. So we've got 8 blocks that are distributed across 3 states. Each of those blocks are about 40 acres in size. They're at least 40 acres in size. And then they've been divided into 4 stands that are each at least 10 acres. And each of those stands within a block gets one of the 4 treatments that I just mentioned. So the 3 adaptation treatments, resistance, resilience, transition, as well as a passive no action treatment that serves as a baseline for comparison. In our particular study, we've got consistency in the soils and soil texture. They're all even-aged or 2-aged stands, about with the oldest cohort about 100 years old, and they're all dominated by northern red oak and white oak with other associated species. So this figure just gives you an idea of kind of what the structure and the species composition look like. Like I just mentioned, northern red oak and white oak dominate both in terms of density and basal area, which is what is depicted here. We've also got black walnut, sugar maple, basswood, American elm, and other species present in the overstory. So a lot of species to work with. The 2 diameter distributions that are shown are fairly representative of all of our blocks. So something close to a reverse J, the overstory dominated by red oak and white oak, and then a greater abundance of basswood, maple, and white ash in the understory. And that's reflected here as well. So this ordination is just intended to show the disconnect that we have between our overstory and our understory, which is fairly common across the region. So our overstory is shown in this multidimensional species space. So it's a flattened ordination so that the location of those plots indicates the species composition. And so plots that are more similar to one another have more similar species composition, whereas plots that are further apart have greater differences in the species composition. And what you're looking at right now is the location of all of our plots based on the overstory, which is dominated by white oak and red oak, but we see differences in species composition when we look at the understory. So the understory is dominated across the study by more mesic species. We see an abundance of sugar maple, a lot of white ash, some hickory, but mostly those more mesic species. So going back to those treatments, with our resistance treatment, the overarching goal is to maintain relatively unchanged conditions. And that's really to make sure that we're able to maintain that oak dominance in those stands. So our desired future condition was one in which northern red oak and white oak dominate those stands with at least 50% basal area or more. We wanted to maintain stocking around 70%, so reduce competition so that those overstory trees that we want to maintain have access to more resources and are more resistant to whatever stressors they may be facing in the near future. We also wanted to make sure that we had a native and sparse midstory, so more analogous to historic conditions. So even though we're trying to maintain the current species richness, we want to really favor the dominance of oak and other mass-producing species. And with our treatments, we also wanted to maintain the potential for future natural regeneration. So with resistance, we weren't intentionally trying to encourage natural regeneration, but we want to try to ensure that we can in the future. And so what that ultimately looks like for us is fairly similar to a lot of the management that is applied currently across this region, especially since we're not really thinking about regeneration yet. We prescribed an invasive shrub treatment, so we're removing buckthorn, bush honeysuckle, and we're also applying a mid-story removal. So any stems between 1 and 8 inches were removed. A lot of that was elm, ironwood. We also had some maple and other species, but I believe ironwood and elm were the most common. We then applied, or are in the process of applying, free thinning to just above the beeline. So it's essentially a crop tree release. So we identified crop trees that we're trying to thin and prioritize, but we also have a basal area target. And the species that we're prioritizing are white oak and other oak species. So largely white oak, and then also northern red and bur oak, and then black walnut, and then other mass producing species after those. And then we plan to repeat the thinning in future years to maintain that stocking around 70%. We have not made the decision yet, but we're talking about including fire in order to maintain that understory. And as I mentioned, with that desired future condition, maintain the potential for future natural regeneration. And then with the resilience treatment, we do have regeneration as an objective. And so with this, the overarching goal is to allow some change in current conditions, but to encourage an eventual return to reference conditions. And so our desired future condition is one in which we have at least 2 cohorts. And then over time, we're hoping to encourage multiple cohorts. We also plan to increase the stand scale, species, genetic, and structural diversity, at least relative to the conditions that were inventoried or observed in 2021 prior to treatment. And we want the tree species to be largely mass producers, so to include a number of mass producers that also are tolerant to drought, to frost, that have some variability in their disease resistance, and also some variability in their adaptation to fire. So this shows kind of the difference between current conditions and what we're hoping for with our desired future conditions. And then these are the tactics that we came up with for achieving this. So we decided on a continuous cover, irregular shelter wood silvicultural system. So going back to what I described earlier, we started with an invasive shrub treatment and a mid-story removal. So removing all stems 1 to 8 inches. And then even though we had planned to use fire as a site preparation method, logistically, that was very difficult, especially since we're doing an experiment and we're having to coordinate across 3 states to make sure that everything is consistent. So we have not used fire as a site preparation method, but we do plan to use it to release regeneration. So we have underplanted native, intermediate, fire-adapted species, and I'll show you a species list for that here in a moment. And then I'll lay out the steps for implementing that continuous cover irregular shelter wood. An example that hopefully makes it a little bit easier to see what I've been describing. So our first establishment cutting involves creating 3 3/4 acre openings in each 10-acre stand. And so we've got openings much like what you see with the blue circle, 3/4 of an acre in size with 1 tree retained. And then we are also opening up 3/4 acre patches that we've called mini shelter woods, but those patches have 40 to 50% cover. So really similar to what you would do with a conventional shelter wood in this region if you're trying to regenerate oak, but fairly small patches. And then in the matrix in the surrounding stand, we're thinning. That's the thinning in order to achieve a 70% stocking target, much like with the resistance treatment. So on the whole, within this silvicultural system, we are creating 3 different structural conditions across the stand. So really trying to increase that structural complexity and keeping in mind also to maintaining continuity by including retention in our treatments. Then over time, in future entries, we would repeat this process. So in the next entry, we would remove the overstory in those mini shelter woods, those 3/4 acre patches with 40 to 50% cover, maintaining or retaining 1 tree, and then create new mini shelter woods throughout the stand, and also maintaining the matrix at that lower stocking. So I mentioned underplanting. We underplanted last spring, and we also plan to plant after harvest, after the timber sale. But the species that we have decided to plant are listed here. Chinkapin, they're all native to the area. Chinkapin oak is not common, but it has a really high drought tolerance, and so we're planting that in order to try to increase the adaptive capacity in these systems. All of the species with an asterisk next to them are species that we're planting 2 seed sources for. So we also have stock sourced from a seed source the seed zone just south that has conditions that are more similar to what are projected for the driftless area in the future. So these are the species that we underplanted in 2023, and we will be tracking their progress this summer. Actually, got a field crew getting ready to go out. And then just really quickly for comparison, our 3rd adaptation treatment is transition. this is where we diverge a little bit from the ecological silvicultural system, because our objectives are a little bit different, because we're trying to actively facilitate change to encourage adaptive responses. The silvicultural system is a variable retention harvest, or clear cutting with reserves silvicultural system. We've prescribed 20% retention when both aggregates and individual trees dispersed across those stands. So still something that we might expect to see in these systems, given the natural disturbance regime. Where it really begins to differ is with the species that we've chosen to plant, because we're actually applying assisted migration and planting species from outside of their current range. But with this experiment, we're hoping to address questions related to climate adaptation, the effectiveness of these treatments. We're also looking at how these irregular shelter woods work in this region where they haven't been applied much in the past. So I want to just briefly acknowledge a lot of folks who have contributed to all of the work that I have talked about today. It's certainly not my ideas, building on the work of many people who've contributed to the literature in the past, and then these folks too directly involved in these projects. I think that wraps it up. I'm happy to take questions if there's time.
Wonderful. Thanks so much. This is fantastic. We do have a few questions. We'll take those. We might run a few minutes over, but really appreciate folks' time and your time today presenting this. So one question was related to just the economic needs and the silviculture that is practiced. So you've mentioned that a lot of places with these small land bases, especially, there's a lot of high grading and essentially no silviculture happening on a lot of lands. And this is common, but it requires a lot of times, people are dependent upon that short-term income. And I was just curious if you've had any reflections from kind of the silviculture work on, what are the economics, and is there, that economic benefit of high grading, or can some of these other practices, be valuable in this context?
It's a great question. I don't have numbers to be able to answer it definitively. So of course I feel more comfortable when I have solid data. But I can say, so just a couple things. I'm working with a large team of people with this Adaptive Silviculture for Climate Change study. And it's been really encouraging to hear, like, they're out in the field, they're talking to private landowners, they're talking to foresters and getting feedback on some of these ideas that we're applying. And there is a lot of interest in trying them out, which is encouraging. And I think there are a number of reasons for that. One, a lot of the private forest and woodland landowners in our area have ecological goals for their land, and they hold that kind of in tandem with economic goals, or maybe they're interested in just treatments paying for themselves, and so that influences what they can do. But also, I mean, the different sites are at different stages in treatment implementation. So it's a big study. And we've completed the timber sale on 3 of our blocks, the 3 blocks in Iowa, and that was a very profitable sale. So we harvested, I should have the number right at hand, but was it because they're partial harvests? So 60 acres were partly harvested. So it's a percentage of that. And it was highly profitable. So the DNR was very excited to have their budget increased a little bit by that sale. And it's not that it was that huge. So we're interested to see kind of how that scales as we go.
Great, thanks. And then one other question is, and this might pull in some of your other research, but can you talk about soil health as a factor to long-term forest health and methods to reduce soil impacts during harvest?
Yeah, it's a good question and an important one. I mean, wherever you're working, and in the driftless area, we deal with steep slopes and There's a long history of erosion given some of the land use practices that have been applied over the last 100 to 200 years. So that's definitely a concern. It's also a concern when you've got agricultural, you've got row crops adjacent to forests. So you tend to have like water hitting those forests, at a fairly high velocity. But in terms of what we do with our harvesting, with operations, most of our forests are harvested in the winter. And that's largely because of restrictions related to bat habitat and oak wilt, but it also serves to help protect our soils. So I don't know what else to say. There's some like cable skidding on the really steep slopes. So it depends on the site. And one consideration also, I guess, with your regular shelter wood and with some of these multi-cohort uneven age systems is you are entering those stands more frequently. And so having a plan for those skid trails is important in order to reduce some of those impacts.
Great. And then one last question is, does clear cutting with reserves in the context of adaptation require less entries over time?
Yes.
Yeah. Great. All right. I think that is good. There was interest in expanding on the site soil features, but you didn't have that information on hand. And so we'll kind of reiterate that people can loop back to you or that those resources do exist, but that sort of that soil and kind of different forest ecosystem types question we try to answer, but I think we'll have to take that one offline. So with that, I will thank you for your time. Thank you for your presentation. Thank everyone who attended today. Great turnout. Double check with Gwyneth to see if there are any other items for housekeeping and encourage people to come to our next presentation in this series. Anything else, Gwyneth?
Not much else. The next webinar series is June 18th. Unfortunately, it seems that this webinar was capped at 100 folks, but that's all right because we have it recorded and we will put it up on YouTube for everyone. And we already have it checked off that next month is not going to be an issue. But yeah, please come to our next webinar series. Haven will be our presenter. And yeah, I hope you guys enjoyed everything.
All right, thank you all.